what is modular arithmetic? Hold on. Can you see my PowerPoint? If not, just tell me in the voice chat if you can see it. Oh, chillax. In this lecture, I will talk about how modular arithmetic how transposition imply modular arithmetic. It's the subject of the lecture. Nice. So let's get started. What is modular arithmetic? In modular arithmetic, the number of non-equal numbers is finite, as opposed to classical arithmetic. How does it work? When we work in modulo n, a, and a means any number, equals a plus k fois n, with k an integer. For example, 24 modulo 10 equals 4. Why? Because 24 equal 2 times 10 plus 4. So you see, we have a limited numbers of non-equal numbers. If we work in modulo 10, we have only 10 numbers that are not equal. Another example, 20 modulo 10 equals 0. Why? Because 20 equals 2 times 10 plus 0. To understand that, I would picture the Pac-Man world. You can picture yourself a line with the numbers, and when you get at the end of the line, you get back to the beginning, just like Pac-Man worlds. You know, when he get at the very right part of the screen, he get to the very left. It's you can also picture it as a circle, a cycle. A clock, for example, you have 1, 2, 3, 4, 5 until 12, and then 13 is the same thing as 1, 14 is the same thing as 2, and so on. You can picture yourself a circle. That's what modular arithmetic is all about. I will check the chat. No questions. Okay. If anyone got a question, you can ask it in voice chat. No questions so far. For example, 16 modulo 14 equal 2, because 16 is 1 times 14 plus 2. Is it understood? You can write okay in the chat if it's understood. Just write okay in the chat. Yeah, it's understood. Fine. Oh, you confuse me, of course. Why? Oh, you take. Okay, but you have to. It's a. Yeah. Just like Felice said, it's like a clock. When you reset to 0 and it continue counting like a clock. Yeah, it's Felice understood the concept of. You can also picture the Pac-Man world. Like I said, when he get to the left of the right of the screen, he come back to the left. Yeah, SPO, you're right. SPO said that mod 4 count like 1, 2, 3, 0, 1, 2, 3, 0, and so on. And 0 can be 8, 4, 8, 4, 16, and every multiple of 4. Okay. No mode at all. No mode at all. When Alekat asked, I have a question. When you consider a daily math, which mode are we using or are we not using mode at all? You are in a conventional arithmetic, so there is no mode. There is infinite numbers of non-equal numbers. What you have to, you go to the, you have an infinite number of non-equal numbers. Now I will work in this lecture with the address of the notes. What does that mean? I will put that C is 0, C sharp is 1, D flat of course is also 1, D is 2, D sharp is 3, and E flat is also 3, E is 4, and you get it. I'll work with the address of the notes. Oh, Feliz is writing. He's writing something. Oh, no worries. Okay. Now we will transpose. We have the C major scale. It's all natural notes. C, D, E, F, G, A, B, C. I will transpose it by a perfect fifth. Why did I pick a perfect interval? Because when we transpose by a perfect interval, it goes well for most of the notes. Like C become G, D become A, E become B, F become C. But there is a diminished fifth in C major. The BF interval. It's a diminished fifth. The interval is too short, so you have to raise the F. B goes to F sharp. We have the D, and now we have the G major scale. It's reversed since the tonic was raised by a fifth, and the fifth, if you start on C and it goes a fifth forward, you get G. Is it understood? If it's understood, write OK in the chat. Oh, Daphne asked me to repeat. I will repeat then. I chose to transpose by a perfect interval because when you transpose by a perfect interval, it goes well for most of the notes. C become G. I have a keyboard. C become G. D become A. F become C. E become B. F become C, and so on. Goes well for most of the notes. But there is a diminished fifth in the C major scale. What is it? The interval BF is a diminished fifth. So if we start on B and transpose by a perfect fifth, we get to F sharp because the interval is too short, and so we have to raise the F. Is it okay now, Daphne? Yes. Oh. Yes, thank you. Yeah, it's a good thing to have. Yeah, I have my keyboard, so we can actually hear what I'm talking about. We have the G major scale. Its reverse in the tonic was raised by a fifth. If we do the same thing will happen. Yeah, I know it's quite obvious written like that, but here we are. All the natural notes of the G major scale will give us all the natural notes, but F sharp will give us C sharp, and B again will give us F sharp. So you have F sharp, C sharp, and a fifth after G, and it's D. To, you have to understand that the source of alteration is the diminished interval between B and F. It's the diminished interval that give birth to all the alteration. Is it understood? Is it understood that the is the diminished fifth between F and B that give birth to all the alteration? Yeah, yeah, yeah. Me, of course, ask. This is also why the cycle of fifth is useful, right? Yeah, because it tells us what note will be sharped. But I made up this method to not to have less to memorize. You have to know about the cycle of fifth, but with this method you won't have to memorize all the key signature with all the tonics. I will go on. Result: transposing a major scale that features sharp in its key signature by a fifth adds a sharp. It's reciprocal, adding a sharp in the key signature waves the tonic by a perfect fifth. So we have a first formula, A, the address of the tonic, equals 7 times n. Why 7? Because a perfect fifth is 7 semitones. And there is a semitone between 1 and 2, 2 and 3, etc. It's chromatic. My labeling is chromatic, so we have to work with the number of semitones of the interval. So the first formula is A equal 7 times n. But there is a drawback. Plot twist. Drawback of the formula. A, the address of the notes can be bigger than 11. And 11 is B, is the address of B, is the maximal address. How to fix it? By using the modulo, of course. That's why I told you about the modulo. Fixed formula, A equal 7 times n modulo 12. Why 12? Because there is 12 semitones, 12 different notes in the chromatic scale. Is it understood? You can write OK in the chat if it's understood. Ah, yeah, it's understood. Okay, okay. I have only 2 OKs. Ah, 3. 3 OKs. Okay, okay, okay. All right. Just one question to be sure. You can ask me your question. Yeah, yeah. The modular thing is basically just a fancy way of saying that octave doesn't matter, and C is still a C, right? Yeah, it's that. It's cyclic, it's circular. Notes, it's A B C D A B C D E F G A B C D E F G A B C D E F G. So we have to modelize this behavior. We have to use the modulo. And yeah, you're right. It's exactly that. You understood the concept. 12 equals 0 equal 24 equals 36 equal and so on. Transposing the C major scale by a perfect fourth. Again, I picked a perfect interval because it goes well for most of the notes. C become F, D become G, B become E. But there is an augmented fourth in the C major scale, the FB interval. The interval is too long, so we have to lower the B. We have to understand that. When it was the diminished fifth, we have to raise the F because to get a perfect fifth. Now the interval is too long. We have to lower to raise the F to have a perfect fifth. It was a diminished fifth. We have to raise the F to get a perfect fifth. The interval now is too long. So you have to lower the B and get then a B flat. We have this F major scale. If we do the same thing, it's an analogous reasoning of the sharp thing. So it works the same way. The non-perfect fourth will give birth to all the alteration, and then B flat become E flat, etc. You got it. Result: transposing a major scale that features flat in its key signature by a fourth adds a flat. Formula. I didn't. Yeah, it's reciprocal, and you get it. I will check the. Can you talk the C calculation? On the page before, yeah. Yeah, yeah, you're right. I forgot examples. Sorry. Example of the first formula. When you have uh, yeah, now with the first formula, when you have three sharps, 3 times 7 equal 21, 21 equal 12 times 1 plus 9, 21 equal 21 modulo 12 equals 9, and 9 is the address, is the label of A. You can, if you don't trust me, you can count C sharp 1, D 2, B, E flat 3, E 4, etc. 9 is A. When we have six sharps, we have C 6 times 7 equal 42. 42 equals 3 times 12 plus 6. That means that 42 modulo 12 equals 6. And 6 is the label of F sharp. So it works. The formula of thankfully works. Yeah, now we have to the fourth, etc. Yeah, the formula is A equals 5 times n modulo 12. Example, and this time I won't forget the example. 3 flat equals 3 times 5 modulo 12 equal 15. 15 equals 1 times 12 plus 3. That means that 15 modulo 12 equals 3. And 3 is not hard to see that it's E flat. 5 flats, 5 times 5 modulo 12. 5 times 5 equals 25. 25 equals 24 plus 1. So 12 times 2 plus 1. So 25 modulo 12 equals 1, and 1 is D flat. Hold on, I will check the voice chat. Yeah, you're right. Modulo is basically the same function as dividing with remainder. 20 times. Well, yeah, you're right. Yeah. It's the division with a remainder. Yeah, it's not very pedagogic of my to not tell you that. And sorry for my bad English. I'm from Europe. Link between fourth and fifth. Since we have 7 a perfect fifth plus 5 a perfect fourth equals 12, a fifth is the evasion of a fourth. It's you have to, when you have a fifth, you have to add a 4 to get to the octave. So transposing forward by a fifth is equivalent to transposing backward by a fourth, and vice versa. Is it understood? If it's understood, you can write as usual okay in the chat. It's understood. Nice. If we transpose a scale that features flat, it's in key signature by a fifth, we remove one flat. And if we transpose a scale that features sharp in this key signature by a fourth, we remove one sharp. Since when we go forward by when we go forward by a fourth and we have flat in the key signature, we add a flat. When we go backward, we remove a flat, and going backward by a fourth, it's equivalent to going forward by a fifth. And if we don't suppose that we choose flat in the key signature by a fifth, we remove one flat. If we transpose a scale of feature sharps in the key signature by a fourth, we remove one sharp. Finding the key signature of a given note. It's pretty hard. I will try to be clear. Here's the algorithm to use. Yeah, a lot of steps. I will explain that. Step 1. Is the address of the note a multiple of 5? Yes. It's trivial. A can be written as 5 times n, and n is the number of flats. If no, then we go to step 2. Step 2. Is it a multiple of 7? Yes, it's trivial. A can be written as 7 times n. N is the number of sharps. Sorry, I made a mistake in the PowerPoint. N is the number of sharps. Hold on. Sorry, I made a mistake in the PowerPoint. If no, then we go to step 3. Step. Oh my god, I made another mistake. Step 3, not 13. Add 12 and go back to step 1. It's a circular algorithm. I will explain it. Step 1. Is the address of the note a multiple of 5? If yes, then A can be written as 5 times n, and n is the number of flats. No? Then we go to step 2. Step 2. Is it a multiple of 7? Yes. A equals 7 times 7 times n. N is the number of sharps. No? Then we go to step 3. Step 3. Add 12 and go back to step 1. And the fact that the algorithm is circular is very easy to understand. Since everything is circular. Everything we use modulo, so it has to be circular. And that explains that step 3 add tail and then go to step 1, step 1, and over. Is it understood? Is it understood? Yeah, you can write okay if the algorithm is understood. Example: A equal 3. Step 1. Is it a multiple of 5? No. Step 2. Is it a multiple of 7? No. Step 3. 3 plus 12 equals 15. Step 1. Yes, it's a multiple of 5. 3 times 5 equals 15. Then it has to have 3 flats in the key signature for E bemol major. Another example: A equal 4. Step 1, no, it's not a multiple of 5. Step 2, no, it's not a multiple of 7. Step 3, add 12 and go to the step 1. Step 1, no, it's not a multiple of 7. Step 1, it's not a multiple of 5. Step 2, it's not a multiple of 7. Step 3, add 12, and then could go to the first step. Step 1, no, it's not a multiple of 5. Step 2, yes, it is a multiple of 7, because 28 equal 4 times 7. And then we have 4 sharp in the key signature for E major. It works. And you don't have to memorize all the key signature. You just have, yeah, I have something. So, yep. Me, of course, says, so the 5 comes from amount of 7 turning 4, 7 comes from 5th, and 12 is just for checking the other octave until the math adds up, right? Yeah, me, of course, yeah, it's that. Feliz Moete says, yeah, I will talk about that later. I imagine it has application when working with less standardized transposition. Yeah, it can work with that. And I will generalize to other modes. It works actually. When we work with Dorian, etc., it's it's very useful, this algorithm. Yeah. Generalization to other modes. The key signatures tells us the collection of notes we're using, but not the nick itself. So far, we worked with major scales, but this method can be extended to the minor mode and of course to all the modes. But we won't consider the church mode in this lecture. Maybe if I have some time left, I will talk about church mode. It's not that hard. If we do the same reasoning with a minor scale, we'll get an analogous result. Since we have a minor third between A and C, the tonic will be lowered by a minor third. If we want to use the formula, we'll have to adapt them. Sharps, for sharp, we have to, it's the same formula, A equals 7 times N minus 3. For the flats, A equals 5 times N minus 3. Minus 3. If we want to use the algorithm, we have to add a step. Step 1, step 0. Yeah, I made step 0. A plus 3. Because A plus 3 equals 7n. It's a basic math. If A equals 7 times n minus 3, A plus 3 equals 7 times n. And A plus 3 equals 7 times 5 times n. Is it understood that with the minor mode you have to you can use the formula, but you have to moving backward by a minor third because there is a minor third between C and A. You can write OK in the chat if it's okay for you. Nice. Enharmonic cases explained. You probably know that there is key signatures that are enharmonic. Enharmonic cases means that it's the same thing, but it has a different name. The first case of enharmony is 5 flat and 7 sharp. Of course, we have 5 times 5 equals 12 times 2 plus 1, and 7 times 7 equals 12 times 4 plus 1. So 25 mod 12 equals 49 mod 12 equals 1. So this first case is explained. It's not very fun, but yeah, it works. The following one is funnier. 7th flat is equivalent to 5 sharp. Why? Because the product is commutative. 7 times, when you have 7 times 5, you can see it as 7 flats. 7 times 5 means flat. But you can also see it as 5 times 7, and 7 means a sharp. Because the product is commutative, you can switch the factor. It's the same thing. Is it okay for you? You can write okay if it's okay for you. Ah, yes! Everyone understand the nonsense I'm saying. And the last one, 6 flat is equivalent to 6 sharp. We have 6 times 5 equal 30, and 6 times 6 equal no, 6 times 7, I made a mistake. 6 times 7 equal I made a mistake in the PowerPoint. 6 times 7 equals 42. But 13 plus 12 equals 42. We made a complete revolution. So we didn't move. If we add 12, we don't move. Since we work in modulo 12, so we made a complete revolution. So it's the same. That explains this enharmonic case. Now you can think about, but we do it together for the first one. You can think about easy generalizing to other church modes and non-heptatonic scales like pentatonic, Arabic scales, etc. And now the hard part is geometrical interpretation. Um, what do I mean by geometrical interpretation? If you, if you want to transpose a note, you are on a line. You work with only one number, and you are in modulo 12, so it's a circle. If you want to transpose an interval, you're not on a circle. You are on a two-dimensional space because you have the first number of hold on, I will honestly ah hold on, I lost my hold on, I lost my little ah I will bring it back. I close it. Sorry. Technical difficulties. Yes, yes. Ah, tac, tac. Ah, it's back. Did in the chat who got the geometrical interpretation. Oh, you got it. Nice. Yeah, I think I get it. Yeah, it's a bit complicated, but it's also very interesting because a chord. Yeah, I can imagine the reason that they don't teach scales at the point of two-dimensional space for beginners. Yeah, you're right. I think Daphne says I think you need to know basic linear algebra to get it. Yeah, I'm an engineer, so um SPO says I think it is a different thing. But SPO, you say it's like points on a clock, but it's only true for one note. When you work in an interval, you are in a two-dimensional space. You are in a two-dimensional space because you have two variables. You have two you see. SPO says I definitely think it's like a point on a clock, but it's a circle. A circle is a one-dimensional thing. And when you want to work with intervals or chords, you have to add some dimension to your space. When you want to define an interval, all the interval possible, you have to be on the surface of a sphere because you have two dimension to your space. Yeah, surface on the torus. Yeah, it's a no, it's supposed to be surface on a sphere, I think. Um, yeah, I don't know. I will have to check it out. But it works on a sphere, and you have two directions, but it also works on a torus. Yeah. Oh, I have some time left, so I will talk you. Ah, SPO is writing something. I'm interested. Yeah, you're right. Ah, I didn't think about that. SPO says because one dimension is a circle S1 and the Cartesian product S1 is a torus. Yeah, you're right. I made a mistake. It's a torus. And then when you add some dimension, but it becomes a weight space, and it's actually a function of 12. We have 12 variables, and then when you are on a 12-dimensional space, you have a point, and then you have a function that transposition is basically a function, and it moves. I do not want to think about visualizing S1 for S1 times S1. Yeah, it becomes a bit weird. Now that I have some time, I will talk about other church modes. Um, you have a minor third between A and and C. If you want to use another mode, you just have to see what is the interval between this mode and C. If you want, for example, to work with Dorian, you have a ninth between a second. It's the same thing of nine. You have a nine uh, between C and D. So you have uh, in the Dorian mode, the formula for sharp will be A equal 10 times n plus 1, and B for the flat, A equal 5 times n plus 1 if you want to work with the Dorian mode. If you want to work with the Phrygian mode, it will be it will be plus 2. Yeah, sorry. 10 for sharp A equal 7 times n plus 2, and for the flat A equal 7 times 5 times n plus 2. If you want to work with the Phrygian mode, it will be A equal 7 times n plus 4, and for the flats, it will be 5 times n plus 4. It works with, it can be generalized to all the modes. Do you understand the generalization to other church modes? Yes, yes, you understood. And I will end my lecture by asking what's the point of all that. Of course, now I have memorized all the key signature for major and minor scales. But when I started to learn music, I used that method, and it helps me to understand what really is going on, and how does it work. You have to when you're a musician, you have to know how and why is there two sharp when it's D major. Why? You have to understand that. When you're a musician, uh, you have to understand what is the mechanism and the mathematical mechanism of music, and how does it work. Music is all about physics, math, psychology, history, and a lot of science combined together, but there is math, and I think that it can be useful to have an insight about how the transposition really works. If you want to say something, you can say in the chat, and if not, I will end the lecture. Uh, Anyone wants to add something or wants more explanations? Yeah, every a lot of people are typing, so I will. I'm. I want to know. when using microtones, um, ah, it's an interesting question. A question. Um, Let me think about it. When you're using microtones, I'm not an expert in microtonal music, so you can use a labeling, label all the microtones, and then yeah, Felice, I agree with you. Felice says there is definitely some application beyond just functioning key signatures that are probably interesting to explore, since some modes have limited transposition, etc. Yeah, but I don't have 5 hours. I don't know if I have 5 hours, so I can't get. I don't want to think about those, so no worry. Me, of course, I suppose it would work with using the cheap way of giving decimal number for microtones. No, no, I won't. Uh, no, I won't do like that. I will label C is 0, then C half sharp is 1, C sharp is 2, C t- ah, C between C sharp and C and D you have a note, a microtonal note, and this note will be 3, and then D is 4, and then go on and on. You have to change the labeling if you want to work with microtonal music. And then if with that labeling, you can transpose. But I don't want to think about how the intervals would be crazy if we worked on with microtonal music. Yeah, well, me of course says, well, yeah, but then we work with all the commodity notes at equal tempo F. Yeah, it can work. Using decimal remove that. Yeah, you can use the most natural tempered, the harmonic series. Yeah, and it can work. It can work. Anyone got anything to say? And if not, I will end the lecture.